All right. There we go. I think I'm good now. Okay. So today's Wednesday. Which, I don't know, like it doesn't feel like a Wednesday. I feel like we've lost total sense of what day it is. Like, because last week we were in school on Monday, but then I came Tuesday, Wednesday, Thursday, Friday. This week we're at home on Tuesday, but we're here on Wednesday. I don't know. What day is it? I don't even know. Like, what's the actual date today? February 10th. Okay. Well, I have it up here. Look. You should realize that. Is that where I am? Like, oh, Mrs. Kane, you have it up there. Good thing I have that to remind me 6 times today what day it is, because I just feel like it's been a whirlwind. And maybe a little snow tomorrow, maybe some snow on Sunday, but you all have a 3-day weekend coming up. So yay for you. Teachers have to be in the building, but still a 3-day weekend for you. And usually that means I get to sit in boring meetings. So yay for me too. There's actually no questions that I saw on the section 6.4 homework. So before we continue, we're just going to kind of practice through problems, look at some power problems, talk about the horizontal line test, but we're still working on inverse functions today. Before we continue through the notes, does anybody have a question that you would like to ask about the homework? Because there weren't any on my form. So I wanted to kind of throw it out there. Anybody at home have a question that you would like to talk about from the homework? Malachi? Yeah, number 2. Anybody else at home want to see one? All right, so we will travel over to the homework worksheet. And these are 2 good problems, 1 and 2. The directions when you do to determine if f of x and g of x are inverses of each other. And then it does say justify your answer with some type of work. So they're saying that we have these 2 functions and we want to justify or determine that they are inverses of each other. And to do that, we need to show, wow, that's really big. That f of g of x equals x. And then I also need to show that g of f of x equals x. So that's how you show if you start with 2 functions. You're not asked to find the inverse. That was the second group of problems. These wanted you to determine if they were inverses of each other. So if I start with the f of g of x part, my g of x function is the cube root of 3x. So we're going to take that function and plug it in the f function. So our f function says 1/3 x cubed. Now remember, you're replacing x with whatever's in parentheses, and I put mine in blue here just to kind of show that it is a different function. So we're not multiplying by it, but we're replacing x. So x is cubed. That means whatever I'm replacing it with has to be cubed. So I have 1/3 and then the cube root of 3x, and then that's cubed. So Riley, if I have a cube root of 3x or cube root of anything, and then that value is cubed, what happens with a cube root and a cube? Yeah, they both cancel out. They undo each other. They're opposite operations. Just like a square root and a square cancel each other out. So if I have a square root and I square it, it cancels out. Same thing happens here with a cube root and a cube. So that means what we have left is 1/3, and then it's just 3x. There is no root anymore. There's no power anymore. Jordan, what's 1/3 of 3? Yeah, exactly. So the 1/3 of 3 is 1. 3/3 is 1. So these guys cancel as well. I'm multiplying by 1/3 and also by 3. 3/3 is just 1. And then that equals x. So that's part of my problem. I've got part of it done. I've shown that the one way condenses down to be the value of x. In order for them to be inverses, we have to show both. So we have to flip it. And now we have to look at the fact that g of f of x equals x. So I'm going to take my f of x function here, which is 1/3 x. And I'm going to place that in for g. So we have the cube root of 3. And then I'm replacing x with 1/3. So my x is 1/3 x. Oops, I missed my cube too, huh? Throw that cube. I have to make sure we have that there. So looking at the inside, I have 1/3 times 3, or 3 times 1/3. Well, we just said that becomes 1. So we're going to have the cube root of x cubed, because my 3 times 1/3 cancels itself out. And then again, a cube root and a cube cancel out and just leave us with. So this is our goal, to verify that they're inverses of each other. They both need to equal x. If one is x and the other one isn't, then they're not inverses of each other. So these work because we have opposite operations. Good question to review. Nice one to start off with. So you were supposed to do that for question number 1 as well, to determine if the functions are inverses of each other. Questions 3 through, 8? Yeah. That's when you're just finding the inverse by switching x and y. And we're going to do a little more of that today as well. Good question to look at. So we're going to go to the notes and work a little bit more with inverse functions. The problems we look at today, we're going to specifically focus on the graph and kind of think about why a graph would have an inverse function. And then we have a little word problem to look at. I mean, you might as well try and look at a word problem. So we are going to look at a word problem as well. So in your packet, we are on page 32. We're going to look at the middle of 32. Yesterday we did the middle, example 3. So we're going to go to example 4, which is right in the middle of 32. And this one actually starts us off by talking about graphing. So it says we're going to find the inverse of a power function. But in order to do that, it wants us to first graph the function, and then it says find the inverse, and then graph the inverse. So we're going to kind of look at what the graph is doing as well of both functions. So the first thing that we're going to start off with is graph f of x. That's the first step. There's a lot of parts in here, so let's talk about that first. So we have f of x equals x squared. And then next to it, it says x is greater than or equal to 0. So how could I graph this function, f of x equals x squared, when x is greater than or equal to 0? What's an easy way to graph? Anybody at home, what's an easy way to graph any function?
Calculator.
Yeah, you could put it in your calculator. We could also make ourselves a tiny little t-chart, and I don't know, Valerio, maybe that's what you meant as well. I'm just going to make a tiny little t-chart here. And we're not even going to pick a lot of values. So Valerio, it says x has to be greater than or equal to 0. Can you give me 3 numbers where x is greater than or equal to 0?
0, 1, and 2.
Yeah, thankfully you picked easy small numbers. And Valerio, if you plug them in for x squared, what do you get out for y?
1, 4, and 9. No.
What's 0 squared?
0, 1, and 4.
There you go. So 0, 1, and 4. So let's plot them. It said x is greater than or equal to 0. So that's why we have to pick numbers bigger than 0 or at 0. We don't want the numbers on the other side of the x-axis. So if I start at 0, and then we have 1, and then we're up at 4. And connect them. Does anybody remember that x squared? We did that in chapter 4. What was the name of the graph of an x squared function? Begins with a P. Riley? A parabola, yeah. So this is half of a parabola. So in chapter 4, we graphed x squared functions. X squared is a parabola, it's a U. We're graphing half of it because it says x is greater than or equal to 0. So here's our graph. The second part says find the inverse of f of x equals x squared. So we're going to now find the inverse. We did part 1, we graphed it. Let's do part 2. Let's find the inverse. So I'm going to switch it to be y equals. To find the inverse, after you make it y equals, Malachi, what would you do next? What's the next step to find the inverse? So we're first going to make it x equals y squared, and then, yeah, then we take the root. So now we square root it, and we use inverse notation. So we're going to have f negative 1 of x equals the square root of x. So this is our inverse of the function x squared when x is greater than or equal to 0. So those are inverses of each other. The last part it says is to graph the inverse. So I'm going to make another little t-chart. Just going to place it right underneath here. I'm going to pick the same numbers that Valerio just chose because I have a square root, so I can't place a negative number underneath there. And I might as well pick those 3 small numbers to graph again. Actually, let's see. Let's don't pick 2 because we have a square root. What's the first number I could take a square root of? Riley? 4. Yeah, let's choose 4 instead of choosing 2. So the square root of 0 is 0. What's the square root of 1? 1. Not a trick question. And then the square root of 4 is 2. So we are going to graph these 3 points, which represent our square root of x function. Starting at 0, 0, I have a point at 1, 1, and then over 4 and up 2. Now, when you connect these, the curve goes the other direction. So I'll show you, I'm going to connect them. And instead of the curve going up, it has now flipped and it's going to the right. You can see that there is a relationship between the 2 graphs. So they are both the same type of curve, except instead of it moving upward, it is now moving to the right. The other thing that I wanted you to notice, yesterday we said an inverse relation can be found by switching x and y. And you can't really see it with the points that we chose, except 2, 4 has switched to become 4, 2. That's what happens with graphs of inverses. The x and the y switch. So if I picked another number, if we chose 3, 3 squared is 9. Well, if I would have chose 9, the square root of 9 is 3. So my x and y switch each time from a regular graph to the inverse. And that's that fact that you're switching x and y, you're switching your input and output values. And you can see in the graph that there is a relationship of that graph. Any questions on that? That happens every single time. So the graph will kind of flip and do the opposite. So it went up, therefore it's going to flip over and go to the right. Anybody have questions? So the last big thing we're going to talk about with these inverse functions is something called the horizontal line test. We actually have 2 tests graphically in math. The first one is the vertical line test. The vertical line test literally looks at a graph and decides if it's a function. It tests to see if a graph is a function. Each vertical line must pass through the graph once. If it does, it's a function. If it passes through the graph twice, it's not a function. The horizontal line test is almost identical, except it's a test for inverses. The inverse of a function f is also a function. So now we're saying the inverse must be a function for the inverse to exist. So the inverse of a function f is also a function if and only if no horizontal line intersects the graph of x more than one time or more than once. So it works the same exact way the vertical line test. The vertical line test tests to see if something is a function. The horizontal line test tests to see if the inverse will be a function. Because we're talking about functions now. So if it's not going to be a function, then I don't have to find the inverse because it doesn't actually exist if it's not a function. So there are 2 graphs shown for you. The one on the left is a curve graph that starts on the bottom and it just increases up. If you do the horizontal line test, they already have one drawn, but if I make another one, as long as my line passes through the graph once, then the inverse is a function. So that's what we're testing. Will the inverse be a function? If it passes through your graph twice or more than once, then the inverse will not be a function. So this is a parabola. A parabola's inverse is not a function. It would not pass the vertical line test. So that means after I find the inverse, if I graph the inverse, it doesn't pass the vertical line test. That's what this is kind of saying. There are 3 more functions on the next page that we are going to graph. Determine whether the inverse of f is a function. If it is, find the inverse. You will be asked to do this on your homework tonight, and I actually have graph paper for each problem for you to graph. If you'd like, you can plug this in your calculator, but I want you to make a little graph. Graph it on the side here. And if you want to plug this function in your calculator, draw yourself a little sketch. So again, you'll have graph paper to sketch the graph tonight for your homework. So right now we're determining whether the inverse of f is a function. And to do that, you actually use the given function and the horizontal line test of the given function. So we're looking at 2x cubed plus 1. Make yourself a little sketch. And I'm just really making a little sketch here. There's a point here and here. think you should have a point at 1, 3, because if I plug a 1 in, 1 cubed is 1 times 2 is 2 plus 1 makes 3. And then you have a point at -1, -3. Or not -3, -2. So it curves up and it curves down. And again, you can plug that in your calculator. I just did a quick mental T-chart. So plugging in a 0, I saw that my x cubed is 0. So I'm going to have a point at 0, 1. Plug in a 1, and then I plugged in a -1. So to determine if the inverse f is a function, you have to graph it. And then using your graph, do the horizontal line test on the graph. If the graph passes the horizontal line test, then the inverse is going to be a function. In this case, Jordan, is the inverse going to be a function? Yes. I'm going to say passes horizontal line test. The next part says, if it is, find the inverse. So now that we know the inverse will be a function, we are going to find the inverse. So to find the inverse, we make it y equals. We switch x and y. And then get y by itself. So to get y by itself here, I know I have to subtract 1. I got to divide by 2. And then to get rid of the cube, we need to take the cube root of both sides. So my function was f. Its inverse would be f -1. The inverse of f is equal to the cube root of all of it, x minus 1 over 2. So the cube root of the entire fraction. This is my inverse function. And I know it's a function because the original graph passed the horizontal line test. Questions? So let's look at letter B. We have the absolute value of x plus 7. Does anybody remember the shape of an absolute value graph? Anybody at home, you can call it out.
It's a V.
Yeah, it's a V. Yes, it's a V. So this V is moving up 7. Remember, that's what that plus 7 does to the graph. It takes the whole graph and moves it up 7. So make yourself a little sketch. There we go. It has to move up 7. So it's going all the way up at 7, and then it's going to be a V. So from the value of 7, it makes a V. Brooke, does this graph pass the horizontal line test?
No.
No. So what does that mean about the inverse then, Brooke?
It's not a function.
Excellent. If the inverse is not a function, you don't have to find it. So you will love the problems that you just make a little sketch. It's not a function. You're done. You get to move on. There's no other work that you have to do for that problem. If it's not a function, you don't have to find the inverse. The last one on here, this one's a little different. It's like the one we graphed on the other side. It's saying that x is going to be greater than or equal to 0. So all of the x's that you choose must be greater than or equal to 0. So it's giving you a restriction on that x. So we'll make a little graph. If you want to, you can make yourself a little t-chart if you think that's easier. Plug in 0, 1, 2. However you think you want to kind of solve this. If I plug a 0 in, 0 squared is 0, plus 2 makes 2. If I plug a 1 in, 1 squared is 1, plus 2 makes 3. If I plug a 2 in, 2 squared is 4, plus 2 makes 6. So I'm going to graph the point at 0, 2. That 2 moved my graph up 2 units. That's what that plus 2 does. And then I have 1, 3, and 2, 6. And then I graph. So this is the same graph that we had on the other page, but this graph moved up 2. Same identical graph. This passes the horizontal line test. So the inverse is a function. And then to find it, I switch x and y. And then I solve for y. So I get x minus 2 is y squared. This graph is an h. This function is an h. So make sure you're using the function h and its notation. So square root x minus 2. So does anybody have questions on determining if a function has an inverse that's a function? That's what the horizontal line test does. So look at the function, graph the original function, do the horizontal line test. The horizontal line test determines if the inverse will be a function. And we're only talking about functions. So if the inverse is not a function, then we're not finding the inverse. Questions? So the last thing we are going to look at is this little word problem talking about the NFL, which just had the Super Bowl this past weekend. It says the average price for a National Football League ticket can be modeled by the equation P equals 35T to the 0.192, where T is the number of years since 1995. Generally, when you create an equation, you have to kind of gather statistical information over a given number of years. So it's not just going to be from the last 2 years, it's going to be from the last group of years. And usually they try and do like a 20, 25 year kind of bracket when they're looking at ticket price or anything to try and find an average of something. So the equation P represents the price of the ticket, T represents time. It wants us to find the inverse model that gives time as a function of the average ticket price. And this is a little different than just dealing with X and Y and switching X and Y. So I'm going to write our function here. So we have P equals 35T and then 0.192. So this says find the inverse model, which gives T time as a function of the average ticket price. So time and price. In this case, we are not switching our variables. We are going to just solve for T. So if I switch my variables, then I'm totally changing what the P represents and the T represents. So instead, we're going to try and solve for T and get it by itself. Questions with that? So with a word problem, you don't switch the variables, you just solve for the other variable. So it says we want to have time as a function of the price. That means we're going to solve for t. So the first thing that you would do, Malachi, to solve for t, what do you think? If I want to get t by itself, what do you think the first thing that we would have to do to get t by itself? Before that, what do we have to get rid of in front of it? What's being done with the 35? Not subtract it. It's being multiplied right now. What's the opposite of multiplying? Divide it. Yeah, let's divide it. You're good. So let's divide the 35. So now I have t.192 equals p over 35. All right, here's the weird thing. We have an exponent of t, and it's not squared. It's to the 0.192 power. So usually we would take a square root or a cube root, but it's not a square root or a cube root. So we are still going to root it, but it would be that 1.92, oops, 0.192 root, 0.192. So it's still the same process. To get rid of it, you have to take the root of that exponent. If it's a cube, I take a cube root. If it's a square, I take a square root, because we're trying to get t by itself. Now, on the other side, right now, we have the square root, or not the square root, the 0.192 root of p over 35. I'm going to write that as an exponent, because we don't really write a radical with a decimal value as the root. So remember, to write something as an exponent, whatever's in the radical goes in the denominator of the exponent. So I have p over 35. This all is raised to the first power because it doesn't have a power. It's raised to the first power. And then the root goes in the denominator of the exponent. And that's from the beginning of the chapter. So t is equal to the ticket price divided by 35 to the 1 over 0.192. Questions? So it's still the same process. We still took a root, but instead of leaving it as that root, because it's a decimal, we're going to think about it as that exponent. So the last part here says, predict the year when the average ticket price will reach $58. Riley, what does that $58 go into? The price. So our price is $58. We're going to plug that into the calculator. And then you're going to take it to the exponent of 1 over 0.192. Use the little exponent, the little caret button in your calculator. Make sure you put that 1 over 0.192 in parentheses so that it's grouping it together. You could even do that number first. Like maybe you would want to do 1 over 0.192 first to get that number. I think that's 5.2. So you're taking 58 over 35 to the 5.2 power, or 1 over 0.192. What'd you get? Did you get a nice number? Yeah, 14, 13.8. Yeah. So in class, we got about 13.8. So I'll say about 14 years. So it says predict the year. If this equation is from the year 1995, what year would be 14 years later? So Jordan, 14 years after 1995 is 2009. So predict the year would be 2009. So if you have Alexa at home, you can ask Alexa what the average ticket price for the NFL was in 2009. We could ask Siri what the average ticket price was in 2009 and see how close this is to $58. And this would be for all of the NFL. I'm sure some tickets, and depending on the city, how good the team is, some might be a little more pricey than others. Does anyone have questions? So when you're solving a word problem, you're solving just for the other variable. You don't flip-flop the variables because then you're really totally changing the representation of the function. So solve for the other variable and get that variable by itself, and then you found the inverse. So your homework tonight is a worksheet. Just want to show it to you so you kind of see what you're doing. The first group of problems, you're just finding the inverse relation. The second group of problems you're verifying, and that verifying is the f of g of x and g of f of x. The next group of problems, you actually are just graphing and saying, yes, it has an inverse because it passes the horizontal line test, or no, it doesn't. So 13 to 18, you're making a graph. You don't even need to find the inverse if it has one. You're just saying, yes, this function has one, or no, it doesn't. And then the last problem is a little temperature problem. So a little word problem like the one we just did. Questions? All right, so have a fantastic day. If you have questions at home, please feel free to stay.